Hello friends. So in this video I am going to start the machine learning in Python, and I will go step by step what steps you need to follow so that you can perform any machine learning algorithm. So in machine learning I already explained that there are two types of machine learning. One is supervised, one is unsupervised, broadly categorized. In the supervised you get the labels, you know the labels, and you wanted to predict those labels in the unseen data set, in the test data set. Whereas in unsupervised, you perform clustering or grouping. You don't have the labels in the unsupervised case. So I am right now going to start with the supervised machine learning. In supervised machine learning you have many algorithms like logistic regression, decision tree, random forest, XGBoost. So basically you have some kind of linear models, then you have non-linear models. So, and also you have which is called tree models. So in tree models what happens is the whole feature data set is divided by binary equations. Like, you already know that what is decision tree. It asks the question in the features that whether this feature is greater than this or not. If yes, then do this. If no, then do this. Recursively it asks the questions across the features, and then it creates the model for the prediction of the unknown data set. So decision tree, random forest, boosting, ensemble models, most of these like random forest and all these are built on the basic concept of decision tree. Right now I'm just going to start with the logistic regression, and it's not a regression, it's logistic regression is a model which is used for classification purpose. So I'm going to start here with the classification problem, and in the next video I am going to tell you what are the following steps which you need to follow so that you can implement any machine learning algorithm in Python. Hi, so in this video I will tell you that what data you need for this complete tutorials in the following tutorials which I am going to make for the machine learning in Python. So we have different models. I will start with logistic regression. For that we need the data, and that data you can download from the website called Kaggle. You just need to write Titanic dataset Kaggle. You just have to sign up there and then just download that data set, and you can then follow this complete tutorials. I hope you have downloaded the dataset from the Kaggle website. Now I'm going to tell you what is Titanic dataset. Basically it have number of variables, and there is one variable which is called survived variable in the dataset. So basically you have to use the machine learning to predict this survival variable. That means whether the person who was traveling on the Titanic ship survived or not after the Titanic sank after colliding with an iceberg. So basically Titanic was a ship which collided with an iceberg in 1912, and it killed 1502 out of 2224 passengers. So you need to predict which of the passengers survived and which of the passengers didn't survive. This is the problem, and you have to predict for the unknown data set. So basically you have two data sets, with one is training data set and the other is testing data sets. So testing data set doesn't have the survived variable. You have to predict for the testing data set with this survived variable, whereas the training data set has all the variables along with the survival variable, from which you have to learn, from which the model will learn the features which are helpful in prediction for the survival variables. Hello guys, so this is the first step in which you have to download the libraries which are required for this project. So the first one is the NumPy, and how you have to import is that you just write import and the name of the library, and then you say that as. That means whenever you will call this library, you will write np instead of numpy. So what you're saying is import the numpy library as np. So whenever you will call, then you will write np in future in this project. So NumPy is a actually scientific library which works with the arrays, n-dimensional array. It can be a one-dimensional array, which is called vector, two-dimensional array, which can be a matrices. It can be three-dimensional, and it can be any dimensional array. And it has a lot of functions, statistical functions and other functions which you can use. Right now we may not require, but usually we if we want to do some kind of manipulation in the data, then it is useful. But let's just import it if we require it in future. Import pandas as PD. So pandas is again a library which is very useful when you have to perform machine learning. You don't have to write each and every code for all the functions and utilities which you need for the modeling and the prediction purpose, because pandas has inbuilt functions which are very helpful for the data manipulations and predictions and everything. So pandas will have pandas series, and it has pandas data frame. So pandas data frame, when you have that pandas data frame, in that data frame, if you want to do any kind of manipulation in the data, you want to filter something, you want to select something, you want to remove the NA values, missing values, you want to fill the missing values with something, you can do all that using the pandas. You don't have to write each and every code in the low level libraries. Then you have scikit-learn. Scikit-learn has all the machine learning models in it, and it has also the libraries packages for the cross validation. So now, and then matplotlib also you have to import matplotlib.pyplot as plt. This is for the visualization, for the data visualization, and scikit-learn is for the machine learning models, and pandas is for the pandas data frame. We read the data in the form of a data frame. So that for that you need the pandas. In the next video we will start with the second step. So this is the second step. So first step was this one. This is first step of importing the libraries, and the second step is to read the dataset. So we have train dataset and the test dataset. Here is train.csv file which I have stored in this path inside the Titanic folder. You can save it anywhere. You just need to give the full path of this dataset. Write it inside pd. So pd is pandas. Import pandas as pd. Then we are using the function read_csv inside the pandas. So this function is basically reading this path file, train.csv, and storing it in this train object. So now whenever we call this train object, it will have this data set train.csv. Just let's run this function. So now we have read this data set. So first was importing libraries, and the second is reading the data set. Hello, so in this video I will be telling about the basic data exploration steps which you need to do, so that after you have read the data set, you just have to peep into the data set, you have to look into the data set, you have to see that what the data features are there, what are the variables are there, and whether these variables have any missing values or not. If they have missing values, how we can fill those missing values. And we would like to see what are the columns names. We want to see that what is the size of the data set. And so let's say if you just want to see the basic thing that how the data set is looking like, just have to see the first few rows. You have to write the train.head. Once you write train.head, and with this brackets like this, round brackets, just have the 5 rows, 0 1 2 3 4. These are 5 rows. and then you have the columns passenger ID, survived, P class, name. These are the columns, and then at the last you have survived variable here. This is the target variable, survived. This is what you need to predict. If you see the test data set, you don't have the survived variable anywhere because you have to predict on the test data set. So we will learn from the train and then we will predict for the test data set. So this is how you can have a look on the data set. So if you see that K-min, this value NaN, this is missing value. There are many more missing values in this. When you scroll down the complete data set, you will find more and more missing values in different columns. Let's now see that how you can see the shape. What is the size of the data set? What is the number of rows and what is the number of columns? So you just have to write train.shape. So it says that you have 891 rows and 12 columns. So like this, these are 1 2 3 4 5 rows, but you have total 891 rows in train data set, and you have 12 columns in the training data set. If you count all these columns 1 2 3 4 5 6 like this, you will find there are 12 columns. So if you guess that what is the number of train in the test data set, it should be 11 because you don't have the survived variable there. So it has 11 columns and observation is 418. So number of observations it's not compulsory that you have the same number of observations in the training and testing data set. The testing data set can be more than the number of observation in train, or it can be less, or it can be equal as well. It depends. Now let's say if you just want to see the number of you just want to see the columns. What are the column names? Just you have to find. It's saying that the column names are these, and you have the indexed as like this. If you want to convert this column names into a list, you just write list of train.columns. You then get a list of all these column names. And now say if you want to check first, you just want to select first one, you just write a square bracket, write 0, you get 1. If you want to select first 3, you write like this. So you're basically subsetting the list. If you want to see the complete list, then this is this list. So this is basically these are the steps for the basic data exploration. There are many more I will be going through in the next step videos. So in this video now we are going to filter the data set. We already know how to select a single column, how to select 2 columns in the data frame, how to convert a series, panda series into a numpy array. We also know how to fill the missing values in a single column by using the fill NA method. Now we will go through how you can filter this complete data set. 891 rows you have. We already see that what is the train shape is, we know the size of train is 891 rows and 12 columns. Let's say we just want to filter, we want to see that, say, give me the data set from this complete data set where the sex is male and the age is between say 20 to 25. We don't want this observation which is female. We don't want this observation which is 38. This complete row will be deleted from that data set. So filtering is basically, we mean to say, based on the condition, and the condition of us is sex is male and the age is between 22 to 35. Conditions can be single condition. Let's say just filter the data set and give me all those observations, all those rows which has sex as male. You can also say give all the observation where the survived is 1. This is also one filtering. You can say that give me all the observations or the rows which have P class as 3. Like this is filtering. So this is, you can either filter on the basis of 1 condition or 2 condition or 3 condition. You can use OR condition and AND condition. So you can use the Boolean operations as ever you want. So I am just going through the basic filtering. For the filtering, what you do, just write train and then write LOC. This is called location. At which location, what location you are filtering it. So you are writing the column name here. So after the comma you write the column name, and you are saying you want those sex in the data set where this sex is male. So you get this panda series. Now, but let's say you not just want the sex column, but you also want the survived column as well. What you will write? You will write like this. So you have this list of 2 columns and you have the condition here. But for writing this, you have to use .loc function. Now you have this data frame, and these has all the rows and observations where the sex is male. You don't have any observation which is female. Now if you just want to write another condition, let's say, so you have to write and you write like this, and you write here survived, and you say that survived should be 1. So all the males who have survived, this is basically saying this, all the males who have survived, you need this. All the males who have survived, these are 1. All males, all who have survived. Let's say you want the ages of all those as well. You will write the list of all the columns: sex, survived, and age. You have this. You want to know that what fear they have given, you can just write here fear. This is a very important filtering process. You can just play with this thing. You write .loc. Before comma you have to write the conditions. You can write either one condition like this, or you can write and condition and multiple conditions like this, or you can choose to write or like this. This is an or operator. This is an and operator. And after the comma you have to give the list of all the columns you need. If you write just one column, then that will be a pandas series. If you write more than one, then that will be a pandas data frame. You can also choose to write store this complete data set which is returned into another data frame like temp df is equal to this. If you do like this, nothing will be shown, but next if you write temp df, it will show the complete data set. Now if you will write temp df dot head, it will give you the first 5 rows like this. So this is for the basic, this is for the basic filtering. You can play with it. You can do a number of things and play with the data set. So now if you want to say filter the data set based on the indexes instead of just instead of using the conditions, what you can use, instead of using the LOC method, you will write ILOC. It's saying index location. You can give the indexes of the rows and you can also give the indexes of the columns. So you are saying basically 0 to 3, that means 0 1 2. So 0 1 2 rows you will select, and 0 1 2 3 columns. So basically it is selecting these. So 0 1 2, these are the rows, and 0 1 2 3, these are the first 4 columns. Here in Python the indexes starts with 0, that's why we are writing like this. But if you write like this 1 to 4, then it will start with survived. If you write here 1 to 3, then the rows will start with 1. So whatever you want to do, you can write it like this. So basically it is just the subsetting the dataset based on the indexes, and the LOC was doing the based on the conditions. In the indexes ILOC you have to write only the indexes. In the LOC you have to write the list of column names and the condition in the before the comma. Now say if you want to completely drop the NA values from the dataset, what you have to write? Write train dot drop NA, and you have to write in place true. In place true, that means you don't have to store this train dot drop NA like this. It will automatically delete the duplicates from the train dataset and store there in the train itself. And if you write access is equal to 1, that is saying that you have to write, you have to drop the columns, you have to drop the columns. X is equal to 1 and in place is equal to true means that you don't have to store this complete train dot drop NA into train again. It will do it automatically. So if you just want to see, you can just drop it like this and then you will see that there are no NA values, but I'm not going to do like that because I will be using the NA values data set, complete data set. We won't be removing the NA values like this. This is just for your information. If you want to drop the duplicates from, then you can use the method like this, train drop underscore duplicates like this, and you can write in place is equal to true again. So these are the basic, and there are many more. So you have to just explore as per your need. To have to Google it and Stack Overflow. You can just have look what's your need is. You can get the this method inside this pandas data frame. So there are a lot of methods inside it. If you just, since train is a pandas data frame, you just write dot and you just hit tab, you will see these are these are column names, and then after these column names you see dot t dot apps means absolute dot add. These are methods that any append, apply, these are so many methods you can use, but depends on what you want to do. So a lot of them. Okay, so we are just going with the basics, what we want to do, and we will be able to perform the machine learning. So in the next video I will go through the data cleaning process. So now in this video I'm going to go through the data cleaning process. We have the training data set, we have the testing data set, we want to clean, we want to remove the missing values, we want to remove the unnecessary values. So we will basically filling the missing values in the numeric data like age and fear. Age and fear is a numeric variable, so we will be filling with the median of those. And basically I will first tell you how you can just write a function in this Python. Just you have to write def, and then just let's take an example. You want to square something, square num. This is the name of the function now, and let's say you are giving two numbers like x comma y. You can input anything in any object, Python object inside the function. You can give the data frame, you can give the list, you can give the dictionary, you can give the set, you can give anything inside it, any object. So what you are returning is, you just say that let's say z is equal to x plus y, and then you are returning z. Once you run this, now your square underscore num is stored as an object. Now you have to call this function, give any two numbers inside it, and just run it. You see that 2 plus 4 gives 6. So this is the demo of this function. The name of the function is a square num. You give the input values x and y, you do some manipulation in x and y, you store as z, and then you return that value. So this is just the basic thing for the function. Now we are using the same now you are using the function for cleaning purpose. We are writing a custom data cleaning function. What you do is just write def, and the function name is data cleaning. You give inside this the name of the data set. You are inputting this data frame. So train data frame you are putting inside, and then you are accessing age, fear, embarked columns, and then you are filling the inner values with the median values, as I already told in the last videos. Now in the embarked column, since it is a categorical variable, you have what you are filling with it is the mode of this embarked, means the highest frequency category in that embarked is S. So we are filling it with S. So now for the male and female in the sex, what you are doing is wherever you have the male as sex, you are putting in 0, otherwise you're putting 1. And similarly for embarked, you have labeled it before you have filled it. Wherever you have the missing values, you filled it with S, and then you are label encoding with numeric values 0, 1, 2. For the sex, wherever you have male, you input as 0, wherever you have female, you have 1. In Embark, you have 3 categories S, C, and Q. That's why you're putting 0, 1, and 2. Now you have everything in the numeric data set. Wherever we have the data which is in the string format or the category, we will not be using, just to make the case very simple, just to get the understanding of how you perform the complete machine learning approach end to end. So just after doing all this data manipulation, you just return train, and then what you're doing is you are calling this function, inputting train and storing as train object, inputting in the next line, inputting test and storing as test. Now train, if you run this, now train and test will be data cleaning. We have not run, so let's run this, and now then run this. Now we don't have any missing values in this. So in this video, we will define the logistic regression model. We already have X and Y. We will just now define the logistic regression model. For that, we need the linear model. And what we are doing is, we already imported linear model from the scikit-learn. So from scikit-learn, import linear model, and from scikit-learn, import cross validation. Cross validation is for the cross validation. We already discussed for that in the earlier videos. So now, what you are doing, from the linear model class, we are calling the logistic regression method, which is a model. This is actually a model, so which is stored in the linear model class. So it has linear underscore model, has different models inside it. It is having also models for ridge and lasso and different models. So we're just discussing the logistic regression right now. So just type like this. You have defined now model logistic, which is the logistic regression model. Now you have to cross validate this model with X and Y we have. That we will do in the next video. Now we will perform the cross validation. For cross validation, we will call cross underscore validation, which we already imported. And now we will write cross underscore validation dot cross underscore val underscore score. That is the method. Inside that, you will fill the method name, model name, which is model logistic, which we have already defined. Then give X and Y, and then give number of partitions of the data you want. So you have 5-fold. Basically what this will do, I have already told, but I am just giving again a certain glimpse of that, what is going to happen. So we have X and Y. It will create 5 parts of it, and it will basically train on 4 parts and then test on the 5th part. It will do number of times like this, train on 4, any 4, and then test on 5. So it gets the understanding of what is the error in the unknown data set without actually performing a prediction on the test data set. It is actually partitioning the actual data training data set into 5 parts and then testing it internally. So training only on 4, not training on the 5th part, because it will if it train on the 5th part and it is testing also on the same testing data set on the same data set, then the definitely accuracy will increase. But we will only train on some data set, and then we will test on the unknown data set. So that's why the cross validation is a very important thing. Now if you just run this, sorry, this is this. Now if you run this, now you have run the cross validation. Now this was the model logistic, how it looks like. It gives all the parameters inside, cost function, cost, and the class weight, dual, fit intercept, whether you want to fit the intercept or not, and all these. You can change these parameters inside. You can give it here. If you want to give C, you can give C point 0.2, anything what you want. I'm not doing that right now. And then if you want to see what is the cross validation values, because we have 5 times we have done the cross validation, the 5 times we get the testing dataset estimate accuracy. That's 79%, 81%, 76%, 76.4, 81.3. These are 5-fold cross validation happened, and we get the 5 estimates of the testing dataset error. These are just the estimates. We have not actually performed the predictions on the actual testing data set, but we have just estimated the testing data set accuracy by just performing the cross validation. Now if you want to see these predictions on the plot, you can just write it like this. So these values, these are plotted, 79, 81, these are plotted in the plot. And if you want to see the mean value of it, just write model logistics CV.mean. So mean value of the testing data set accuracy estimate is, this is estimate, 78.9. So if you now perform the prediction on the testing data set, it should be around this. Not sure, but definitely based on the cross validation, it is saying like you will get an estimate of this much. So in the next video, we will perform on the testing data set. So now we have already performed the cross validation on the training dataset, and we have seen that the model is performing well on the training dataset. We have done the 5-fold cross validation and we got an accuracy of around 78.9. So now we would like to perform this model on the complete training dataset. We were doing 5-fold cross validation, but we will now perform the complete training dataset, take the training dataset and perform the logistic regression. We will once again define the logistic regression model like this. We will fit this model by using the dot fit x comma y, and once you write dot fit x comma y, the model has fitted on the training dataset. Now for the predicting, you use the model logistic dot predict function, dot predict, and if you want to predict on the training dataset, then you write train and predictor vars. You get the predictions like this. Now if you want to predict for the test dataset, then you write here test. But for the test dataset, in this we don't have the survival variable, so we can only give the predictions. But if you want to match that whether our predictions are matching with the actual ones, then for an example I am taking the case, but it doesn't make sense if you train on the same data and you also predict on the same data. But for the demonstration purpose, I am training on the training dataset and performing predictions on the training dataset and then matching it with the predictions and actuals to get the accuracy score, just for demonstration purpose. But you should always predict for the unknown dataset and then validate with the actual values. So let's predict, and then you have to import just one library. From scikit-learn, import metrics, and then you write metrics.accuracy score. So these are actual values, train.survived, and these are the predictions which you already did here. So if you run this, you get 79% accuracy. Similarly, if you write train.survived, if you have that data set, then you can do this like this. But what you can do is, from the trained dataset, you can make two parts. One is training dataset and one is again testing dataset. And then keep that training dataset part and train on that part only, and leave that testing dataset part and then validate on that. That set you can say as a validation set. So basically, before you had train and test when you download it, then what I'm saying is divide this train dataset into two parts: train df and validation df, and then only train on this part. Right now I just trained on this complete training dataset. We did the validation on this cross validation. What I'm saying is, now you perform the cross validation on only this and see the cross validation score, and then train the model on only train df instead of this complete data set, and then test on this validation df, because this validation df will also have the survived variable, and then you would be able to match the predictions with the actual values. So this is how the complete machine learning algorithm you can perform for anything: decision tree, logistic regression, random forest, or any algorithm. These are just the basic steps which you need to follow. I hope you have understood. Thanks for watching.